In this video, we're going to see how you can use the SPARKvue data analysis tools to measure the change in temperature of your calorimeter after you've added a cold metal mass to the water. This is activity that will be done outside of the lab, so you're going to want to make sure that every student leaves with a copy of the SPARKvue file that you use to take the data. That's accessed through this main menu up here, and you'll always be able to open up a previously saved file by clicking on open here. So make sure everyone has the SPARKvue data file. You can analyze it later at your convenience. So let's see how you would do that. So say you've gone home with a SPARKvue file that looks like this. You took one data run, which was really not very good. You're not going to be able to analyze that, but you want to analyze this red one down here below. So you can always click off any of the runs that you're not using by clicking inside the box. Let's do that there. I've turned off run 1. It's just run 2. If you want to maximize the data run, you come down to this scale to fit button, and now we have a nice data run that's completely filled the screen. You might want to submit this data run in its entirety to your grader. Include this in your lab report just to show them what the entire data run looked like. We won't be analyzing the whole thing, but you would at least want to include one copy of this. So when you're analyzing the data, the first thing you're going to want to know is what was the initial temperature of the water. One of your lab partners was measuring the initial temperature of the metal mass. That should be somewhere around 0 degrees. So you'll know that from the other data file. But you want to know what was the temperature of the water right when you added the mass to it. So to do that, we're going to want to zoom in on this point a little bit. So let's, again, go down to not the hand icon, but this little orange square, which is toggle move select mode. We can zoom right in on that corner. Let's just do something like that. So I'm going to highlight and zoom in on that corner, and then always go to scale to fit, and then I can zoom in on something like that. So what you want to do now is you're not going to actually guess at what these data points are. You click on this add coordinates tool right here. So you add the coordinates tool, and this is a bar that allows you to read off the little different data points. I can left click in that and drag it to wherever I want. So if I want to know what that data point was, it'll tell me. If I wanted to know what these data points was, it'll tell me. But note if I just go to say this data point here, it has these blue arrows. So I can scroll backwards. It's going to step through the data. So if you just look at the data and you're trying to decide when does it start to change, so just look at the values here. It's giving you the time and the temperature measurement. So 54.94, 94, 94, 94, 94, 94. Clearly nothing changed. 94, 92. Boom, then it drops to 89. Clearly it has started to change there. So if you decided that 54.94 was the temperature right before it started to drop, I would probably agree with you, and that would be your initial temperature. So it's going to be very important that you write down the time, 237.400 seconds, and 54.94 degrees C. So record those, and you're going to be using that in your analysis. That's the initial time and the initial temperature. Okay, so that's one thing we have. Now we have to go back and analyze the slope of the decrease in temperature after we've done that. So we have to get out of this view. You can always undo things in SPARKvue by, look, I'll click in it and see the blue X, it's gone. Click inside this red box, that's a left click, blue X, and it's gone. And then scale to fit, and it brings up the whole screen again. Now I'm going to be wanting to analyze this long, slow decline here. So again, I'm on the orange box selected. I want to analyze a region that looks kind of just like that. I just want to zoom in on that. So I want to see what that looks like. I'm going to want to be analyzing this data here. So what I'll do is I will left click. Oh, I grabbed the wrong thing. Again, you can always draw any box and you can zoom in. So I maybe want to analyze this data. I'm trying to click on that little blue circle there. There you go. And I can drag this. Now here's where the variability comes in. You and your lab partners may very well decide to fit different linear regions. That's entirely possible. There's nothing we can do about that. That's why you're analyzing it on your own. But I'm going to want the linear fit of this data region here. So once again, I go to the show hide linear fit. Now we have this beautiful linear fit, and you only should select the data that's lying along that fit. If your data does not lie along this linear fit, then don't select that bigger region. This was really good data that has 50, 100, 150, almost 200 seconds of really linearly decreasing data. And so what I'm going to need out of this fit is, here's the equation it's fitting, y equals mx plus b, and now we're going to need both m and b. M is negative 0.00451 degrees C per second, and the intercept is 53.3 degrees C. Neither one of these are the answer to what the final temperature was, because remember, to calculate the specific heat, we need the initial temperature, which we just obtained, and now we need the final temperature. We're going to use the time at which the metal was dropped in, and we're going to insert that into this equation to determine what the final temperature was. And that'll be explained in a different part of the lab manual. This is showing you how to obtain this fit and that initial temperature. Hope that works out well for you. Good luck.